Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday Night Math Night. It is so good to see you. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons, and I just love what we get to do, which is help you build your confidence and competence in your math ability, because we all know that, yes, you can have all of the confidence in the world, you can have all the competencies, you can have all of the skills, but if you don't walk into that test with confidence, then you are going to struggle, and vice versa. You can have all the confidence in the world, but you just need a little help with those skills. And so that is why we are here on Wednesday nights. And that's why we exist, truly. Like, that's why we have boot camps. That's why we do tutoring. That's why we do all the things, is to help you build that skill set. Before we get started, I always like to do a get to know you. So in the comment box, let me know where you're from, what test are you prepping for, and get to know you question. Where are you from? What test are you prepping for? And are you an animal person or not? Like, are you a dog person or a cat person? And I only ask because my Great Dane is sitting right here next to me. Normally he's not allowed in here while I'm recording, but tonight is just a unique night. And so Pudge is laying right next to me. He's 160 pounds of Great Dane, so he's a big boy. Maybe one day I will share. Let me see if I can find a photo of him so that I can share that with you guys. So in the comment box, tell me where you're from, what test are you prepping for, and are you like a dog person or a cat person or an animal person? Or are you not an animal person or a dog person or a cat person? I always like to do like a little next week section. And so in the comment box, let me know if there's something specific that you want to see me go over, and I'm happy to go over it. If there's something specific that you want me to go over, and I will be happy to go over it. There's Pudge. I found a picture of him. So there's my big boy. Like I said, he is 160 pounds of smush and love, and he loves his lovey toys. So let me know, are you a dog person or a cat person? And what do you want to see me go over next week? And I'm going to add that section right here. Next week, I love including things that you specifically ask for. So you can comment on this YouTube video or this Facebook video. You can find me on Instagram or Facebook, and you can let me know, and I will absolutely include those in the upcoming weeks. I think that's it. So without further ado, let's go ahead and go over our first problem. If x equals 4.7, what is the value of 3x plus 5 square roots of x plus 11.3? If x equals 4.7, what is the value of 3x plus 5 times the square root of x plus 11.3? All right, so this is a good one. This is really just plugging in a value of x for the expression that they give us. This is an expression, not an equation, because there's no equal sign. And so we know it's an expression. And that said, we can go ahead and just plug this value that we have right here in for each x that we have, and we can go from there. So 3 times 4.7 plus 5 square root of 4.7 plus 11.3. And you might be asking yourself, why am I not just doing the square root to the 4.7 and then adding 11.3? That's a great question. These parentheses right here tell me that the square root symbol does go all the way across because the parentheses are there. If the parentheses were not there, if it was written just like this, then the 11.3 would not be included. If it was written like this with no parentheses, then the 11.3 would be included. So it's all about the notation of what we're looking at. So 3 times 4.7, I'm going to use that calculator. 3 times 4.7 is 14.1 plus 5 times the square root of, and I'm going to do what's in those parentheses first, order of operations. So 4.7 plus 11.3 is 16. Now I can evaluate the square root symbol. So I have 14.1 plus 5 times, what is the square root of 16? 4 or negative 4, because 4 times 4 is 16, but negative 4 times negative 4 is also 16. So I'm going to plug in 4 here. I could plug in negative 4, but I can already see in my answer choices that I'm going to need to use that positive 4 instead. 14.1 plus 5 times 4 is 20, and 14.1 plus 20 is 34.1. So I can quickly see that my answer is A. That was a pretty quick first problem, wasn't it? Questions about that? All right, pretty straightforward. Let's move on to problem number 2. The sum of 2 consecutive even integers is 50. What is the value of the square root of the smaller integer? The sum of 2 consecutive even integers is 50. What is the value of the square root of the smaller integer? So this is a fun one. This is a play on words for sure, because we are having to use our understanding of the English language to interpret this, right? So what does the word sum mean? What does the word sum mean? Sum means answer to an addition problem, correct? So we know that we are doing addition here. Sum of two consecutive. What does consecutive mean? Back to back. What is an even number? 2, 4, 6, a multiple of 2. And what is an integer? Like a number, yeah, like a whole negative or positive number. And that sum is equal to 50. So they want to know what is the value of the square root of the smaller integer. What is the value of the square root of the smaller integer? So they're not looking for the smaller integer. So I know I'm adding two things, two consecutive even integers, and I'm going to get 50. Now, I could do this very algebraically. However, sometimes our brains just don't work like that. Sometimes our brains just don't work like that. So if I'm doing two consecutive even integers, it could be 2 plus 4. It could be 4 plus 6. It could be 6 plus 8. It's not going to be 6 plus 7 because 7 is not an even number. But none of those are going to even come close to 50. I know that 25 plus 25 equals 50. So if I'm looking for two consecutive even integers, I know it's going to be in those 20s, correct? So I'm going to start with 22 plus 24. That equals 46. So not quite enough. 24 plus 26. That equals 50. 24 plus 26 equals 50. So they want to know what is the value of the square root of the smaller integer. Well, the smaller integer in this case is 24, so it's going to be the square root of 24. Well, that's not a choice, but that doesn't mean that I'm wrong. All it means is I might have to simplify it. What I do know is that it's not 5 because that would be the square root of 25. And I know it's not the square root of 26 because that's the larger integer. So now I can use my factor tree to go ahead and solve this. So 24, I can split into 2 times 12. I'm just going to bring that 2 down. 12 is the same thing as 2 times 6. I'm going to bring all of those 2's down, and 6 is the same thing as 2 times 3. When I do a factor tree and I'm trying to figure out the square root, I'm looking for pairs. When I find a pair, I can pull 1 out. So this means that I can pull 1, 2 out, and I'm left with 2 times 3, which is 6 in the middle. So the value of the square root of the smaller integer is 2 square roots of 6. Questions about that problem? No? All right, let's go ahead and move on to the next one. Look at the following equation. What is the value of x? What is the value of x? 3 to the 2x minus 6 equals 81 to the 4th power. 3 to the 2x minus 6 equals 81 to the 4th power. All right, so this one is interesting because we've got this equal sign and we need to be able to solve for an x value. We need to be able to solve for an x value. So in order to do that, I really need to get that x out of my exponent. Now, I could log both sides, but that's going to get really messy really fast. So what I want to do is I want to see if I can get both of these to have the same base. Because if they have the same base, then their exponents are going to be equal to each other. Like 2 to the 4th power is going to equal 2 to the 4th power, right? Like properties of equality. But 2 to the 4th power equals 2 to the x minus 7. That just means that 4 is going to equal x minus 7 because 4 is going to equal 4 if 2 equals 2, right? So we can use our understanding of equality to set those equal to each other. So all that said, how could I solve this? Well, I want to see if I can get this value, if I can get that to have a base of 3. Is 3 times 3 times 3 times 3, however many times, ever going to equal 81? And if the answer is yes, then I've got a winner, right? So I know that I have 3 to the 2x minus 6 power over here. I can't simplify that any further. But can I simplify that 81 down to a value of 3 as my base? Well, let's see. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So 3, how many times? 3 to the 4th power equals 81. So if I do 3 to the 4th power to the 4th power, all I've done is substitute the 81 with 3 to the 4th power. That's all I've done is I've substituted this 81 value with 3 to the 4th power. Now, it is not 3 to the 4th power plus 4. It's 3 to the 4th power, and then 81 is 2 to the 4th power. So we have to do the power to the power. What do I do when I have a power to a power? I multiply them. So this becomes 3 to the 2x minus 6 equals 3 to the 16th power. And you say, Amy, why is it to the 16th? Like, why am I multiplying it? Well, let's chat about what does an exponent actually mean? It means I'm doing whatever that thing is that many times. So I'm going to do 3 to the 4th power 4 times. So I have 3 to the 4th power times 3 to the 4th power times 3 to the 4th power times 3 to the 4th power. So I have 3 to the 4th power 4 times. And so that's why we multiply, because when you multiply a base and an exponent like this, you add the exponents. And when you have an exponent to an exponent, you multiply. Well, now you're like, why do you add? Great question. Because this is the same thing as 3 times 3 times 3 times 3 right there. Times 3 times 3 times 3 times 3. Times 3 times 3 times 3 times 3. Times 3 times 3 times 3 times 3. So this becomes 3 to the 16th power, right? So now that my bases are the same, now I can set those exponents equal to each other and solve like a pre-algebra problem. So 2x minus 6 equals 16. And now I can just solve like an algebra problem. Add 6 to both sides. 2x equals 16 plus 6 is 22. X equals 11. Questions about that problem? All right, I will say, I can't see your comments tonight, so I'm sitting here going, do you have any questions? But I'm not able to see your comments tonight, and so if you are asking questions, I promise you I will answer them. Please don't not ask questions. I promise you I will answer those questions next week. I just can't see those comments tonight. So if you're asking questions or you're like, man, she usually says hello when I come, that's why, because I can't see the comments. But when I can see the comments, I will absolutely answer those questions and get back to you. Like I said in the beginning, let me know what you want to see me go over next week, and I will absolutely add it to our next week list. That just helps me cater to your specific needs. So let me know. All right, let's go ahead and move on to problem number 4. This is a long one. A teacher asks her students to represent the number 43 thousandths in different ways. Students showed this number in the following ways. Student 1 said 0.043. Student 2 said 0.04 plus 0.003. Student number 3 said 43,000. And student number 4 said 43 divided by 1,000. Which student has a misconception of how to represent the decimal 43 thousandths and why? So anytime it comes to a student error analysis, anytime we have student error analysis, I always like to solve the problem myself and then look at the student errors. Because if I'm solving the problem myself, then I'm able to figure out, oh, that's why that's there, or oh, that makes more sense. And so it's important for us to recognize that. Some of us are really good at just looking at student errors and understanding it, but I like to personally solve the problem myself and then look for the student errors. So let's take a look at this. The students are to represent 43 thousandths. What do you notice about that specific number? There's a 43, but there's this th at the end of it. And what does that mean? That means we are working with a decimal. Exactly. If it said 43,000 in different ways, then we would be looking at a whole number like 43,000. But because it says thousandths, we are looking at a decimal. So student number 3 is absolutely going to be the individual that has the misconception. They misunderstood that this is supposed to be a decimal. Now, it could be careless or it could be a true misconception. We're not sure because the student is not in front of us. But it absolutely is student number 3 because thousandths represents a number less than 1 or a decimal. Now let's look at some of the other reasoning and just talk about it for a minute. So student number 1, because the number 43 thousandths should be written as 0.43. So if we talk about our place value, this is our ones place. This is our tens. This is our hundreds. This is our tenths. This is our hundredths. This is our thousandths and 10,000ths, right? And so I've never understood why we don't have oneths, like why did we start with tenths? But anyways, because the number 43,000 should be written as 0.43. 0.43 would be 43 hundredths because of where that number stops, right? So it's definitely not that one. Student number 2, because the teacher did not ask for an addition expression. That is one way that we can represent. In fact, this would be expanded form of the number. Expanded form of the number. We're expanding it into its different place values. And so that absolutely would be 43 thousandths. And this literally reads 43 over 1,000 or 43 thousandths. Like literally that's how it reads. So student number 3 is absolutely the correct answer. Now, if we look at student number 4, this right here would be 430 thousandths, which would be written like this. And then that 0 would be able to be dropped essentially because it holds no value because of where it is. But this 0 cannot be dropped because it represents a totally different number, right? If we dropped that 0, we would have 43 hundredths and not 43 thousandths. All right, let's move on to problem number 5. How many ways can one select 4 colors from a set of 17 unique colors without replacement if the order does not matter? How many ways can one select 4 colors from a set of 17 unique colors without replacement if the order doesn't matter? If the order doesn't matter. All right, so this would absolutely be the combination formula. And people often get combination and permutation mixed up. But this would absolutely be our combination formula, which says n factorial divided by r factorial times n minus r factorial. And I'll read that again. N factorial divided by r factorial times n minus r factorial. Or sometimes you'll see it as n minus r factorial times r factorial. So with that said, what does all this mean? N is the number of things I have total, and R is the number that I'm selecting. So this is the total number I have, and this is the number I'm selecting. So in this case, I have 17 total that I'm using, and I have 4 that I'm selecting out of that 17. So I have 17 total, and I have 4 that I'm going to use in this scenario. So I'm going to plug in my values. 17 factorial divided by 4 factorial times 17 minus 4 factorial. Now, what is factorial? Factorial is 17 times 16 times 15 times 14 times 13 times 12 times 11, all the way down to 1. So let's go ahead and write that out because I want to show you something. 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. I'm going to run out of space, so let's move it down a little bit. Times 5 times 4 times 3 times 2 times 1, right? And then divided by 4 times 3 times 2 times 1 times 17 minus 4 is 13. 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Because all of this is being multiplied together, I can cancel out common factors. So 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, 9s, 10s, 11s, 12s, and 13s can all cancel out. So I'm left with 17 times 16 times 15 times 14 divided by 4 times 3 times 2 times 1. Let's go ahead and do that in our calculator. 17 times 16 times 15 times 14 equals 57,120 divided by 4 times 3 is 12 times 2 is 24, which equals 2,380, which is A. And that is the combination formula. That is the combination formula. Questions? So permutation. So some of you are like, well, what's the difference between this and a permutation? A permutation cares about the order, and a combination does not care about the order. So a combination means that order doesn't matter, And a permutation means that order does matter, which allows for more opportunity, because in a combination, if I can do red and blue and green and yellow, but order doesn't matter, then red, blue, green, yellow would be the same as blue, red, green, yellow in a combination, because order doesn't matter. But in a permutation, those two things would be totally different because order does matter. Does that make sense? So in a combination, order does not matter, and that's why there's less options, because I could literally arrange these in so many different ways, but it would all count as one. Whereas a combination, I could arrange these in a variety of ways, and all of them would count as a separate way that I can organize these colors. And so that's why there would be so many other options. In fact, the permutation would literally just be 17 times 16 times 15 times 14 if order mattered. And that's why we would get 57,120. But if order doesn't matter, then we have to divide out those potential different orders. And so that's why you have less with a combination than you do a permutation. All right, let's go ahead and go on to problem number 6. Mason has a drawer full of marbles. He has 18 blue marbles, 7 green marbles, and 25 white marbles. We're going to call those marbles. Marbles. What is the probability that he picks a blue marble, holds onto it, and then pulls out a white marble? So this right here is probability without replacement. This right here is probability without replacement. So we have 18 blue, 7 green, and 25 white marbles. Let's remember that probability equals my desire out of my total outcome. So in this case, my total outcome is going to be the number of marbles in my bag. And so I have 18 plus 7 plus 25 marbles in my bag. And my desire at first is to pull out a blue marble. Then my desire is to pull out a white marble. So how many blue marbles do I have in my bag at first? 18. So 18 plus 7 plus 25 is 50. So I have 18 out of 50. But then if I want to know the probability of something and then something else, I'm going to multiply those two probabilities together. My next probability is going to be my desire out of my total. So how many white marbles do I have? 25. And how many marbles do I have in my bag now? 49. Because I'm holding on to that blue marble. So now I can not cross multiply. I can solve and multiply straight across. So I can multiply straight across, or I can go ahead and simplify while the factors are still split out. So 25 and 50 can simplify. So I'm left with 2. So I have 18 over 49 times 2. And 18 can simplify with the 2. So I have 9 over 49, and that cannot simplify any further. And I know exactly what happened here. When I was building these answer choices, I built them for replacement, not non-replacement. I built them for replacement. So I built them so that I am putting that blue marble back in the bag and then pulling the white marble out, which would then be 9 out of 50. But in this case, it's not 9 out of 50 because I'm not replacing that blue marble. I'm holding on to it. And so that's why it's 9 out of 49. The next problem is a very similar problem. So let's go ahead and look at it. Mason still has a drawer full of marbles. He has 18 blue marbles, 7 green marbles, and 25 white marbles. How many marbles would he have to pull out to be guaranteed to have 2 green marbles in his hand? How many marbles would he have to pull out to be guaranteed to have 2 green marbles in his hand? So this is a really fun one, and it's kind of a different one than we're used to. So Mason has this drawer full of marbles, and there's 18 blue, 7 green, and 25 white. So let's put all the blues together. Let's put all of the whites together. I can't write white on white, so I'll use the black marker. And I have 7 green. So if this is my bag right here, and I'm pulling out marbles, how many would he have to pull out to be guaranteed? Not like it's likely, but guaranteed. Well, theoretically, I could reach my hand in the bag and pull out all the blue marbles first, correct? Now, we're not talking about likelihood here. We're talking about a 100% guarantee. We're talking about a 100% guarantee. So I could pull out all blue marbles first. And then I could pull out all the white marbles first, correct? So if I pull out all the blue and all the white, and I don't have any green marbles in my hand, now there's only green marbles left. And so I can pull 2 marbles out, and now I'm guaranteed to have 2 green marbles in my hand. So let's add 18 plus 25 plus 2. 18 plus 25 plus 2 equals 45. Now, I want you to remember, this was not a likelihood question. In fact, this is extremely unlikely that this would happen. But they didn't ask us for likeliness. They asked us for a guarantee, a 100% guarantee. And so that means that I'm looking really for that unlikely event that I would pull all the whites, all the blues, and then would have 2 green marbles. There's a likelihood that you would have 2 green marbles before that, but that's the first time that it's actually guaranteed. Questions? We are ending just a little bit shorter today just because of some situations. So we are ending a little bit shorter today. However, I want you to let me know in the comment box what you want to see me go over in the upcoming weeks. I'm going to turn it back over to Dr. A, and I will see you guys next week. But let me know in the comment box what you want to see me go over so that I can make sure to include that in the upcoming sessions. I do have like student error analysis of linear functions, I think, on tap for next week. So let me know in the comment box what you want to see me go over. I will keep an eye out for those comments of things that you're like, hey, I really would like to, like if you have questions about what we did tonight, I will keep an eye out for that. And I look forward to seeing you next week. I hope you have a great rest of your week. And I'm going to turn it back over to Dr. A now. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.